Consider the functions f of x equal to 2x cubed minus 9x squared minus 108x plus 2. There are multiple parts to this particular problem. The first part is I want to ask you to find the critical numbers of the functions. To find the critical number, once again, you have to take the derivative of the functions and set that equal to 0. So the derivative of the function is 6x squared minus 18x minus 108. To set this equal to 0 and you solve for x. To solve for this, you can see that 6 is the common factor, and you're left with x squared minus 3x, 18 equal to 0. So you can divide both sides for 6, and you're left with x squared minus 3x minus 18 equal to 0, and you can factor the quadratic equations. You have x minus 6 times x plus 3 equal to 0. So the critical numbers are x equal to -3 and x equal to 6. The next part is to test the sign of f prime of x. Alright, so for this test, you have to draw the real line with the critical numbers on that. So draw the real line with x equal to -3 and x equal to 6. Right, so this is -3, this is 6, this is x, this is f prime of x. So at -3 and 6, those are critical numbers. The derivatives, it's going to be 0 at those points. Alright, so because you have f prime of x earlier up here, right, you factor this out. You can divide both sides for 6, but I'm going to keep 6 for now. It doesn't change anything much, right? So f prime of x is 6 times x minus 6, x plus 3. So when x equal to -3, this term is 0, right? So f prime of -3 is equal to 0, and f prime of 6 is also equal to 0. So that's why at those critical numbers, the derivative is equal to 0. By consider the critical numbers in here, you separate the real line into 3 different intervals, right? So we're going to test the sign. We are going to test the sign of f prime of x in 3 intervals, right? From -infinity to -3, from -3 to 6, and from 6 to positive infinity. All right. So in -infinity to -3, you choose any numbers within this interval. Right? The easier for you to calculate, the better. Right? So choose x equal to -4, and I'm going to substitute this into the derivative functions. So that is f prime of -4 is equal to 6 times -4 plus 3 times -4 minus 6. So as I mentioned, you don't necessarily have to calculate the exact solutions. You just need to consider the sign of the derivative, right? So that is, this one is negative, and this one is also negative. So therefore, f prime of -4 is a positive number. Right? So you go here and you put the plus sign. That's for the first interval. Now for the second interval, you have from -3 to 6. I'm going to choose x equal to 0. Like I say, the easier for you to calculate, the better. So you have f prime of 0 equal to 6 times 0 plus 3 times 0 minus 6 is going to be a negative number. And in the last interval, so in the interval from 6 to positive infinity, I'm going to choose x equal to 7. So f prime of 7 is equal to 6 times 7 plus 3 times 7 minus 6 greater than 0. So this should give me positive. That is, you say that f prime is positive in the interval of -infinity to -3, and from 6 to positive infinity. And f prime is less than 0 in the interval between -3 and 6. So let's move on to the next part of the example. So I would like you to indicate the interval on which the function is increasing. Right, so the function is increasing when f prime is positive, right? When f prime is greater than 0, f is increasing on the interval -infinity to -3, and from 6 to positive infinity. So indicate the interval on which the functions is decreasing. So what do we have here? Right, so decreasing functions, that means f prime is less than 0. So f is decreasing on the interval of from -3 to 6. So E, find the local max and mean values. So that means I want you to find the output. Go back to the chart here. I'm going to just copy and paste because you have that in your notes already. You have f prime here and also f of x. For this f of x is increasing here, decreasing, and increasing. So therefore, at this point, you have a local maximum. And at this point, you have a local minimum. You need to find the local max and local min values. How would you do that? You just substitute that this x equal to -3 and x equal to +6 into the original function to evaluate the local maximum and local minimum values. So substitute x equal to -3 and x equal to 6 into f of x. Right, so f of -3, so 2 times -3 cube minus 9 times -3 square minus 108 times -3 plus 2. And I have the last one is f of 6 is equal to 2 times 6 cube minus 9 times 6 square minus 108 times 6 plus 2. And so this is 191. And this one is -538, right? So you make the conclusions that local maximum is equal to 191 at x equal to -3, and local minimum is equal to -538 at x equal to 6. So one last question. This is just to give a taste of the higher order derivative, and eventually next week we're going to learn about something called the second derivative test. So part E, determined the second derivative of the functions, and find the value of x. You could say values of x when f double prime of x is equal to 0. So f double prime means that this is the second derivative. So the first derivative we got, right? First derivative is 6x squared minus 18x minus 108. And take the second derivative. That means you take the derivative of this expressions right here. Right? So the second derivative is 12x minus 18. Okay, so that's the second derivative. And to solve for x when f double prime equal to 0, set this equal to 0, you solve for x. Right? So this is 12x equal to 18, or x is equal to 18 divided by 12. Well, this is equal to 3/2.